In order to get started with functional programming, it is important to understand what it is. Then we can dive into the techniques and methods that are used as a part of this pattern. When introducing paradigms, I provided a brief definition about functional programming. If that definition made sense, then great. But I have found that there are thousands of definitions out there and very few make sense unless you already know what functional programming is. And that is because the functional approach implies a different way of writing programs, a different way of thinking about solutions. So I'm going to try to introduce it in a bare bones fashion. And I will do some comparisons to object-oriented programming since that is something we now understand. So first, any program consists of two main things, data and behaviors. Data in JavaScript is usually an object or an array or something like that. Behaviors are functions. Now, with object-oriented programming, we saw that these two things were combined. The methods of an object acted on the data that object contained. With functional programming, these two things are separated. Data is completely separate from the behaviors, which are the functions. These two things are not combined. Now, another way to say this is that data is manipulated by passing it through a series of functions. One function acts on a piece of data and then returns a new piece of data. That new piece of data is then passed into another function, and this continues until we achieve the desired effect. So functions act on well-defined data structures instead of belonging to those data structures. Let's look at an image to help illustrate this. Now keep in mind this is a very simple example, but it can provide some clarity. So here we have data in the form of text over here, very basic data. And we pass it into a function, format post. And this little diagram here is going to represent updating posts on a form or something like that. So it's going to format the post. We get the text, it's going to format the post. It returns an HTML node. So it has some HTML code around it. That's the new data piece that gets returned. That gets passed into another function, decorate post, which adds something to it to make it look nice, some CSS or whatever. And so that happens there, and that returns back something we're going to call colorized HTML. And then that gets passed into a function that updates the form. So basically, we're passing data from one function to another, and it changes that data as it gets passed through. Now, another element of FP is using functions with other functions. In fact, most functions in FP are simple and straightforward. When we need a more complex function, we create that by combining other functions. This is termed composition. Let's look at our image again. I'm going to add a little bit to it this time. Now, notice this decorate post function. This is actually created by combining or composing other functions. We have a function that checks to see if the post has been read, one that checks and sees how old it is, and then one that adds a class. So those three together, composed together, make the decorate post function. That's what happens within decorate post. So FP emphasizes writing functions and connecting them to produce more understandable and more easily tested code. Some very important points about functional programming. Now, in OOP, we talked about the 4 pillars that support an object-oriented paradigm. These 4 pillars provide a way for us to break apart and talk about OOP. Now, in FP, we rely very heavily on a single concept, pure functions. This is something that we will look at pretty closely in upcoming topics. Now, another important concept in FP is that data is immutable. Now, what does that mean? Well, basically, it means that once we have a data piece, we don't change it. Now, this whole idea might make you wonder, well, how can we accomplish anything if we can't change data? Aren't we passing data between functions and changing that data? And that we are. But the important thing to understand is the original data is not changed. A new piece of data is produced. And that includes the original data and that changed. And then that new piece of data may go into another function and it may create another piece of data. So it's not changing the original piece of data. Now I want to illustrate this with a bit of JavaScript. So let me jump to a code file here. Now notice what we have. We have an array and it contains all kinds of different pieces of data. And what we want to do is we want to pass this array through a function, and we want to find out if each of the values within each element here exist or not. And so the only thing we're going to consider not existing is null and undefined. So those don't exist. Those are the two ways we can define non-existence in JavaScript, is null or undefined. Everything else exists. Even though the object is empty or the array is empty, it still exists. It just doesn't have data inside it. So to do this, we're going to create a pretty simple function. This is a function you might use with functional programming. We're going to call it exists because we simply want to find out if a value exists. Now, a value is going to get passed in, and then it's going to return. This is going to be an arrow function. It's going to return either true or false to indicate that it exists or not. And how are we going to do that? Well, we can do that very simply in JavaScript using this operator and checking to see if that is not equal to null. So if it's not equal to null, it will return true. So what happens with undefined? Well, because we're not using triple equals or triple non-equals here, because we're using this operator, it will coerce those two values to be the same. And so in both those cases, those will come back false. All right. So it's a very simple function, and we want to apply it to this array. Now, how do we go about doing that without changing the array? How do we get back whether this is true or false, meaning there is something there, without changing the array? Well, JavaScript contains some very helpful methods for doing this that are tied to arrays. And we're going to look at the map method. Now, in this section, because these are widely used with functional programming, I will get into these later, all three of them. But right here, I just want to use the map method. The three, just for information's sake, are map, filter, and reduce. But what we're going to do here is we're going to declare a new variable, new array. So this is going to return a new array. And this is the point I wanted to emphasize here. It's not updating this array. It's going to return a new array. And so we'll have both arrays when we're done. This new array will be related to this array in the sense that it indicates whether these values in here exist or not. But that's all. It's not going to update that existing array. Now, how are we going to do this? Well, we're going to take our weird array and we're simply going to map over that. Now, what map does is it goes through every single element in an array, and then it applies each of those elements to a function. Now, what function are we going to apply it to? Well, that's the first parameter we can pass in to the map method. And you guessed it, we're going to pass in the exists function. So there are other things we could pass into this function using map, but right now, all I care about is the value of each element. As it goes through each one of these, it's going to pass each one into that. It will check it here, and it will return the results into a new array. So that's all it takes. And we're not going to change this array right here. So let me go ahead and save that. So let's go ahead and serve this up, and we'll take a look at it. So here we are. If I jump to the console now, I want to take a look at new array. And there we go. Here's an array. True, true, true. This is null and undefined here. Those are false. All right, so that's what we got. But can we look at weird array as well and see if it has changed? And it has not. So there we were able to act on data without changing it. It is immutable. We consider it immutable, so we don't want to change it. All right, now a few final thoughts before I finish up with this getting started section. We're already a bit long here, but I want to give a few additional thoughts. First off, functional programming has a lot of restraints, such as pure functions and immutable data. And as a JavaScript programmer, these restraints help us make very predictable code. However, some might argue it restricts our creativity. But I don't think that is the case. I used to have a professor in college that talked about the false dichotomy that rules restrict creativity. And he would use the sonnet as an example. Now, the sonnet is a poetic form in English literature. The sonnet is a very restrictive pattern for poetry. But working within those restrictions, we can still be very creative. In fact, it might require more creativity. Some very beautiful sonnets have been written over time, which reflects this creativity that happens within a restrictive pattern. One final thought. Remember that FP is not an all or nothing thing. The idea is not to throw away everything you have learned and apply functional programming techniques instead. The guiding principle in adopting functional techniques should be a gradual approach that will improve your coding. Even though you may not use all of its techniques, just starting to apply some of them will pay dividends with better code. So as we move into the methods and techniques of functional programming, remember this idea. All right, let's move on.